Hey, Vsauce, Michael here. Sometimes, when I say things, I feel like I'm repeating myself. Like, I'm going in circles. But what is a circle? A set of all points equidistant from another single point on a two-dimensional plane? Or is it? Let's take a circle of diameter 1 and put it inside a square of side length 1. It's a commonly accepted fact that the ratio of the diameter to the circumference of any circle is a constant, approximated as 3.14, and commonly known as pi. If we take a square-shaped area off of each corner, we now have a cross-type shape still with perimeter 4, as the following operation would be similar to folding the corners inward. As we can see, the section folded inward still has the same perimeter as before. This process can continue indefinitely, and the perimeter of the edited square remains as 4. As it becomes closer to a circle, is the circumference of the circle 4? If this is true, the constant of pi as we know it is wildly inaccurate by nearly 0.86. How could we be so off? Here's another square with side length 1. According to the Pythagorean Theorem, the sum of the squares of the lengths of the two non-hypotenuse sides of a right triangle is equal to the square of the length of the hypotenuse. 1 plus 1 equals 2. Therefore, the length of the diagonal line, which we'll call x, should be the square root of 2. Let's find out. Let's take a square-sized chunk of side length 0.5 off of this square. Now take two smaller square-sized chunks of side length 0.25 off of our new shape. The total length of the new staircase is 0.125 times 16, which is 2. The new series of lines will always remain at a total length of 2, even as it infinitely conforms to the diagonal x, supposedly the square root of 2. Now, 3, 4, and 5 is a classic Pythagorean triplet commonly taught in grade school that many of us take for granted. Will it work? Let's see. We'll take a rectangle of side lengths 3 and 4 and draw a diagonal down the middle, which should be 5. If we take a piece out like we did with the square, we'll see that the length of the staircase is 7. Let's repeat. 0.75 plus 0.75 plus 0.75 plus 0.75 plus 1 plus 1 plus 1 plus 1 is 7. The sequence can continue on infinitely until it becomes the diagonal line of length 7? But how is this possible? What creates this upside-down world where pi equals 4, a squared plus b squared isn't c squared, but a plus b equals c? The answer is Taxicab Geometry, Manhattan Geometry, or Rectilinear Distance, named for Manhattan's infamous grid-shaped roads. In this geometry, all distances work normally, but you can only turn at 90-degree angles, forming a grid. In ordinary Euclidean geometry, in order to go from point A to point B, you would simply draw a line between the 2 points. However, with rectilinear distance, the simplest way is to navigate to its position on one axis and then go to its position on the other. But what could this be used for then? Well, the most obvious use is to get from point A to point B in a real-life grid of streets, hence the name Taxicab Geometry. Another common application is found in chess to measure the distance between a rook and another piece on the board. The rook piece can only move up, down, left, or right, and cannot move diagonally. This matches with the principles of rectilinear distance, in which you can only move on a grid. What other uses can you find? Let us know in the comments. Even if there aren't any, it's always nice to look at things through a slightly different perspective.